Okay, welcome back to ELM Prep Part 18. We'll be looking at factoring. I'm James E, and hopefully you've enjoyed the series, or if you're just coming into the series at this point, you might want to look up other related videos. The goal is, of course, to prepare yourself to look at the questions on the ELM test in a logical manner. I don't go into a lot of detail on specific questions here. I look at types of questions. So factoring, there's a lot of things about factoring. I might be looking for, one of the things you can look at is just reducing a fraction, 4 over 8. One of the things I would look at is the factors of 4 are 2 and 2, and the factors of 8 are 2 and 4. Another factor of 4 is just 4 and 1, and then 4 and 2 for the bottom. And then what we would see is, this would be our best choice, where we had 4 and 4, and they cancel out, leaving me with 1 over 2. At this point, the 2's would cancel out. I would have 2 over 4, but I would see that this still factors down into 2 times 2, and so I would take another 2 out of that and end up with 1 over 2. So factoring can be as simple as just finding or simplifying a fraction. If I have 3 over 5, both of these numbers are prime numbers. They will not factor down into anything that is common to each other. The only factors here are 1 and 3 and 1 and 5. And factoring out of 1 is useless because I essentially get right back to where I was. So if I have prime numbers and I'm factoring, the fact that I know it's prime helps me. I won't waste effort trying to factor a prime number. Once I get to primes, I'm done with my factoring. So let's look at a fundamental idea of why would I factor. Let's say I have 3a squared b cubed over 2ab to the 4. They might give you something like this and say, okay, reduce or simplify this. Well, looking at my numbers, they're both prime. 2 is the only even prime, so I'm not going to reduce that any. Knowing my primes helps me decide that. Well, now I have letters. Letters are very straightforward. I have 2 A's on the top and 1 on the bottom. So I'm going to take 1 away from the bottom, and I'm going to take 1 away from the top. I have 3 B's on top. I take 3 away from the top and 3 away from the bottom. And so I'm left with 1 A on top, right here. And I'm left with 1 B on the bottom. And so my reduced or factored fraction is 3a over 2b. Let's talk a little bit about this. I'm going to break this out just a little bit so that I'm not, let's say I have b squared over b cubed. Well, this is really equal to b times b and b times b times b. And I'm just going to add a 1 in here, because anything times 1 is just itself. We normally understand that 1 times the 1 is out there, but I'm putting it in just so that we don't lose track of that fact. Well, I've got b over b, so b over b is just 1. Anything over itself is 1. b over b is just 1, and that leaves me with 1 over the remaining b, so my reduced answer is, in fact, 1 over b. Now, 1 is the universal number, as I call it. 3 over 3, 17 over 17, square root of 5 over square root of 5, a squared over a squared, abz over abz. If the top and the bottom are the same, it all equals 1. This is, I call this the magic tool of math. 1 can be anything, so it lets me use that value to do all sorts of things, like factor numbers out, get rid of radicals in the bottom, rationalizing, things like that. Okay, so enough of that about my universal tool of 1. Let's go back to factoring. What if we have a to the 1/2 over a to the 1/2, we'll say 3/2. Well, now I'm a little puzzled because I'm not sure what to do with fractions. But if we go back to the idea that I'm subtracting top or bottom the same number, I'm going to look at, if I take 1/2 away from this, I will have a to the 0. That's what I would like to have. Something to the 0 power, because a to the 0 equals 1. Well, I'm happy about that. So let's do the same thing to the bottom. I'm going to subtract 1/2 from the bottom. A to the 3/2 take away 1/2 is going to leave me with a to the 2/2, which is just a to the 1, right? And a to the 1 is just a. So my factored answer here ends up being 1 over a. Well, the answer seems simple enough. When we first looked at this, though, we saw fractions and we go, oh my goodness, what are we going to do with that? But as we saw, the fundamental idea of factoring helped us out. So what if I have a to the minus 3, b to the 2 over 2a, b, 3? Okay. Well, I want something to be equal to 0. Well, I can't do anything about the number. That's just going to be 1 over 2. I'll just write the 1 out there. I look at my a's, though. I got minus 3 up here and 1 down here, essentially. A plus 3 would make that a 0. So I get a to the 0 up there. Well, that's just 1, so I'm happy about that. But if I add 3 up there, I'm going to add 3 at the bottom. Over here, I'm going to make this, the lower number, equal to 0, so I'm going to subtract 2 there and subtract 2 there. This becomes b to the 0, which is just 1. This was 1, and so I end up with nothing but 1 on top. On the bottom, I end up with a to the 4, and 3 take away 2 is 1. I get b to the 1. So there is my answer. So even though I had a negative exponent initially, I still followed the same pattern of creating an exponent to the 0. All right, so 3 over 6 a 2b minus 1/2 c, I'll just make this a b, b 2c. All right. Well, I have a's on top, but no a's on the bottom. So the a's are going to stay on top. I'm going to start with my number here, and notice that 3 over 6 will reduce down to 1 over 2. So I'm done with the numbers. I have no a's on the bottom, so my a squared is going to remain. I'm done with that. I have no c on top, so the c on the bottom is going to remain. So I'm done with that. So now I'm left with my b's. Well, a minus value is smaller than a plus value anytime, so I'm going to turn the smaller one into a 0. So I'm going to add 1/2 to that. And so that'll be b to the 0, which will just be 1. Well, I'm going to add 1/2 down here. So then this will become b to the 2 and 1/2. And, or if you want to change that to an improper fraction, that would be b to the 5/2. So you could have a b to the 2 and 1/2 or b to the 5/2. Either one of these would be the same answer, and it just depends on what the test answer would be. But the idea here is I make the smaller ones equal to a 0 exponent, whatever I have to do, whether it's add or subtract. So I want my exponent, nice, to equal 0. 3 to the 0, a to the 0, z to the 0, doesn't matter. They all equal 1. Okay, we've run out of time once again. Hope this was informative, and I will do a little more work on factoring. Obviously, we have to look at factoring quadratic equations and looking for common factors in a binomial. Well, stay tuned. Hope you're enjoying the series. Have a good day.